directories are mostly classified in terms of how they are able to perform a certain job. So that's why if you look at the single level, it's able to perform some jobs, but it's not more efficient because the users, we only have one user at a time, and this user is able to perform a given function at a given time. Then that's why we said we are having a one directory, but this has one entry. So you are having one entry. And for this entry that we are having, we must enter to each and every file. So you can see that now this directory, they have their own files. So if now the directory 2 want to share with file directory 1, it can't share. So these files, they don't allow sharing of files. That's why you look at now, one advantage, it is, since it is a single directory, implementation is very easy. If you can remember, we said it's very easy. It is smaller in size, so searching will become faster. Remember, we are searching one at a time. But you look at now disadvantage, we said searching will become time-taking or consuming if the directory is too large. So it's like we are having a very large directory, so it will take time to search for those files that we are supposed to search at a given time. Then it cannot group the same type of file together. So meaning that if you have the same file, you have to create a different directory. So it can't group the same type of file. So we are having duplication of files. So we said we can resolve that maybe through the use of a two-level directory. And I remember what we said, we have what we call the master file directory. And this is the master file directory, which is allowing user 1, user 2, user 3, and user 4 to do a specific communication. So in this case, what we can understand about this, we have many users, but these users are able now to access different files at different levels. So it means that if user 1 has the same directory with user 2, it can still work. If user 3 has the same directory with user 2, it can still work. We don't have any issue on that. So we can allow what you call sharing of files, a bit of sharing of files. We can give full path like username directory. I remember we talked about two paths, absolute and relative pathing, where absolute pathing, we said it starts from the directory or the root directory, then up to the files that we have. Then we have what you call the relative. The relatives start immediately after a specific directory. So it is after a specific directory. So disadvantage, user is around to share. User is not around to share files with other user. So that is one of the disadvantage. So if user 1 is having a file, but you want to share with user 2, it's very hard, because each user has its own files in that case. Then we said we can now improvise that. We have the 3-level directory. And in a 3-level directory is where now we extend the tree. And when you extend the tree or branches, so automatically we have what you call subdirectories. And within these subdirectories that we have, we can now allow some sharing of files, of which now it is not even clear in sharing these files. We have still some issues on the sharing of the files that we have. So for this case, we can be able to understand the concept of how these files are supposed to work within the representation. And that's why we said when you're using the 3-level directory, we can look at a point where there is more directory created within them. And when there are more directories that are created, we can be able to understand this concept of some duplication of files. And in the duplication of files, we will be able to look at now an aspect of data presentations. So in this case, we need to understand the use of the file where the same file can be accessed in another directory, which has already been presented by the user. So in this case, we are now improving in file access. And because we are improving in file access, now it is resulting to more way of accessing it. So that's why we said very generalized, since full path name can be given. Very scalable, meaning if it is scalable, you can be able to add more subtrees, or you can be able to add more connections within them. So in this case, that's why we need to understand that in this representation of a directory that we are supposed to have, we can be able to look at the presentation of the files that we are supposed to have in a very special way. So just a minute, I respond to this call. So if you look at what we are looking at here, we are saying it is very scalable, meaning when you look at scalability, we are looking at expanding the tree, because now we have directory, subdirectory, and subdirectories. Then such become very easy. We can use absolute as well as relative. Remember here, we were saying when you're using absolute referencing, it's where we are accessing from the root directory. But this one we are accessing from the immediate file. And that's why I was using some presentation, like maybe if we are using C, maybe then use CMD. Maybe we can see that using CMD. If I have a file, that means this is the immediate directory. So if you say this is a directory, this becomes the immediate directory. So we are accessing the immediate directory. This is relative. But from C onwards, that is what you call the absolute referencing. Disadvantages, we cannot share files. That is one thing that we have seen here. We cannot create a sharing of files, becomes an issue. And with this presentation, we need to understand that the basic is, are we able to share files? And are we able to look at now the presentation of data within the files that we are having? So in this case, we need to understand the concept of efficiency and inefficiency. So we still look at inefficiency. It is inefficient because accessing a file may go under multiple directories. And what we are saying is that if you want to access this, we are having the directory. Maybe we have directory here. We can still have directory here. We can still have directory A here. So we have multiple representation of directory, which is an issue when you are presenting data. So it becomes hectic, mostly when you are accessing them. And that's why it was able now to dominate to what you call a cyclic graph directory. And in a cyclic graph directory, I remember we said we are allowing what you call sharing of files. I think we can see these files are shared, where we can share this file, and this directory is shared with this. And if you can look at this, okay, we have this directory. Then on this directory, we have another directory which is not of the same family with this. And this directory is now having a file, but this directory is sharing a file of a directory that is coming from a subdirectory A, where this is subdirectory B, meaning we have some sharing of files. So we don't have duplications, we don't have repetitions, we have reduced what you call repetition and duplication of files. So that is why we are saying we can share files. Searching is easy due to the different parts. So we are looking at these different parts. So we are moving from this to this, moving from this to this. So it means that if this is able to access this file, so the directory that is here, it is able to access this directory that we are having here. So which becomes easier in the access. So in this case, we can be able to understand the concept of file sharing each other or file being shared from one directory to another. We don't look at maybe whether it is coming from directory X or Y in that. There is another one that is called general, of which I always classify these with a cyclic graph directory. But if you look at this, we are having a two-way communication. So if you look at this, we are having a one-way communication. So there is no big difference. This one, we are having a one-way communication. We cannot go back. But this one, we can replicate directories. You either replicate this directory to this. That's why we have a two-level directory, a two-way of communication. So which allows cycles, which is more flexible because you can move at any point. You don't have to move to the previous executions. And then we can be able to look at the execution in the way they are supposed to be. So in this case, we need to understand on how we can be able to store data in files. And the way we can be able to store these files, that is when we use what you call file techniques or file allocation methods. And that is the next subtopic that we are supposed to revise within the file systems. Within the files, we try to understand, yes, we are having these directories, but how will you allocate the files? How will you allocate the data or the information that we are having? So there are three main file allocation methods. One of them is contiguous, the next one is linked, and the next one is what you call the indexed allocation. When you look at the contiguous, we are looking at following each other, meaning if you store the file in the first allocation, we will be able to create another new executions within that. And that is what we can be able to understand with the execution of these processes that we are having, meaning the allocation method defines how the files are stored in the disk blocks. There are three main disk space or file allocation methods. One, contiguous allocation. So in a contiguous, we can be able to allocate one after the other. So that's why we are using a concept. Maybe I can use a paint. Maybe I can use paint. So if this is the allocation of where we are supposed to allocate in the physical allocation, so we are assuming that the first size is 0. Then we have the second size, which is 1. The next size, which is 2. The next size, which is 3. Maybe the next size, which is 4. Because we are starting from 0. That is the index of 0. Then maybe we have 5. So what we need in this allocation, we need the file size. And we need the file name. And we need the start bit. We need the start bit. Meaning, if this is the name, we are having file A, it has the size of 5. That is the file size. Since it has the size of 5, maybe the start bit is at 0.2. Meaning, if you are looking at the allocation using contiguous, we allocate this one here. We allocate 2, 3, 4.
5.
Then we have 5. So meaning, we have already accommodated the 5 files. Let me call them 5 files. If I have another one, B, and want to start at 2, that one cannot be accepted because already 2 has been accommodated by the file A. So if 2 want to start from 6, which is around, because we are starting from 6, if you start from here, and now we need to do some scalable, and we add this file. Instead of 5, we have 6. Instead of 5, we have 6. So automatically, we will come and create it to where B will end. And that's why we find that there is what you call defragmentation of files. There is fragmentation, sorry. There is fragmentations of files. And if there is fragmentation of files, it means these files are now dispatched from the other, where files are supposed to be contiguously arranged. So the moment we're accessing the files, it becomes hard. The moment you are trying to add a file, it becomes hard. So that's why we always say that when you're using this kind of an interpretation, it is always hard when you want to add a certain file. That's why if you look at this diagram that we are having here, we are saying the scheme contiguous set of blocks on the disk. For example, if a file requires n block and it's given a block B as a starting location, then the block assigned to the file will be B, B plus 1, B plus 2, B plus n minus 1. So in this case, we can be able to understand that this file that we are having here is able to create some contiguous allocation of these files. And this contiguous allocation of these files is the one that now, which is complicating the allocation. And you can see this. One of the files that we have a count. The start bit is at 0, but the length is 2, which is now the size. So we can have 0, 1. Then the next one is TR, which is having a length of 3, but it's starting at 14. So we start at 14, then we have 1, 2, 3. But we cannot move back. We can go ahead on the file that has to be used as a start bit. Then we have the male, which is 19. Start is 19, but it has 6. So we are starting from 19. 1, 2, 3, 4, 5, 6. Then the next one is the list that you are supposed to store, which has 28. Start bit is as 28, but it has 4. 1, 2, 3, 4. The next one is F, 6, which start at 2. So when you look at 2, the length is 2, but it starts at 6, 1, 2. So in this case, if we need to add the first file, and maybe we want to add 10 of them, so automatically we will have some issue in communication. And this issue in communication is the one that is resulting to what you call inefficiency in the access. And that's why we can see it uses a sequential and direct access method, because we must move from one bit to another. We cannot go immediately to the one that was created before. We have to move from one bit to another. And when you move in that way, we will be able now to understand the allocation. The method suffers from both internal and external fragmentation. I think that one I have covered. Increasing the file size is difficult because it depends on the availability of the contiguous memory allocation. So we have seen, if you want to allocate, or maybe if you want to add the size of the first one, and you want to add the size which is too small, too big, then it will be able to communicate. And when it tries to communicate, we will have now what we call hibernation, or we'll be able to so I'm in class. In that, we will be able to improve in the execution. So that is now the concept that we will be able to understand. And if you understand about the disadvantage that we have, it speaks loud on the inefficiency of the method that we are having. The next one is linked. But if you look at linked, there is one thing that is created. And that one thing that is created is called pointers. And you move from a given pointer. You move from a given pointer to another pointer. So it means there is a specific address that has already been created. So meaning it's like now we are having this file and we store, this becomes a pointer. Then there is a file here. Then here, there is a pointer. So if now we do away with this pointer, that means this is the end of that file. So that is what we have within this. But the advantage is it is easier to access. We cannot lose data. We cannot lose content because we are having contiguous allocation of these files. So in this case, we need to understand on how we can present that. Meaning that if we have a file, but the start is 9, but it is supposed to end at 25. So it means you must know the size of these files so that we can be able to link them. And that is how I want you to see here. I want you to see something here. And in this case, we'll still use the same method here. So this is 6. This is 7. Maybe this is 8. So if you have a file, and this is file A, and this one have a size of 5, and the start bit is as 2, so automatically we must know the first file is 2. Maybe we can have another one 8, maybe we can have 3, maybe we can have another one 4, maybe we can have another one 1. Those are the files that can be created on that. So you must know the files that you are supposed to interlink. So if you are moving from 2, you move from 2, you interlink with 8. Then when you interlink with 8, you interlink with 3. Then when you interlink with 3, then you interlink with 4. Then when you interlink with 4, you interlink with 1. So that means there is that chain of communication. And that chain of communication is the one that is resulting to an easy access of data, to an efficient access of data. Because when you look at this, you can be able to find some lenient in the access of this data and in mode of access that you're supposed to have on that. And we'll be able to understand how to access them. You can use serial or you can use sequence access method. But the problem is when this pointer is out of connection, so automatically the file that is beyond here, so you can only access 2 and you can only access 3. So the other file is very hard for you to access them because you have done away with the pointer. So pointer is one of the advantageous point within the linked communication. And in this one, we can also call this, it is also called chained. It is also called chained method. It is also called chained method, meaning we are forming some chain of communication in that aspect. So in this case, we'll be able to understand that this is not a very good method of which it is somehow flexible. So we are saying this is a very flexible in terms of file size. The method does not suffer from external fragmentation. So at least we have reduced the external fragmentation. And if you look at the execution of this process that you are having, it is becoming easier when you're trying to access these files. But the disadvantage is it does not support random or direct access method. It does not support random. You cannot move directly and then you try to access this. It is not like when you're using this method, I can say I want to access 15 and I go directly to it. But for this case, you have to move from one point to another. Then, in this case, we can be able to form some link of communication. So when you form this link of communication, you must move from one bit to another. So you cannot move to this. If you want to access this, which is 10, if you want to access 10, which is here, automatically you must move from this to this. You must move from this to this in that access when we are using what you call chained access. But the last one is what you call index. And when you use index, it's very easy for you to access. And I think you have covered indexes in the data communication. And mostly when you're doing ICT, where we have said we are following an index. So these are supposed to move from a specific block. And that's why we can see they are supposed to move from a specific block. And the specific block is from 19. So anything that you are storing, it must move from 19. If there is loss of data, you have to trace it from 19. If you cannot trace it from 19, now automatically that is the loss of data that you are having. So it means if this file is removed, automatically all these files will still be accessed. So you can access these files. It doesn't matter whether you have removed or not. So it doesn't have interference of the other. That's why we are saying to support direct access, it overcomes the problem of external fragmentations. The pointers ahead of the is greater than linked allocation. So when you look at this method, we are now linking them. But when you are linking them, the best thing that you are supposed to notice that we must have an index that you are moving from, so that we can be able to access this data that we are having. So that is now what we are supposed to look at in file allocation methods. And in this file allocation method, we try to understand that the best one that you can use is this, because we are using an index the moment you are trying to access these files. And it will become easier for you to allocate them when you want to allocate them in the access. And in this case, we can be able to understand the concept of process communicating with each other in that forum. So unless you have a question, maybe I repeat. If you have a question, I can repeat. Maybe if you have a question, if you don't have a question, maybe you can tell us maybe where we want us maybe to move back to, so that we can maybe revisit the point. So I'm waiting for, I'm giving you 5 minutes. Maybe you ask questions that you have.
So the best allocation method is indexed, or? Hello?
Mwalimu ameenda offline.
Unashangaa. Eh?
Well, stick offline. I'm waiting for a question.
And
yes, come here.
What is the best allocation method?
So the best file allocation method is the index. Because now, if you look at these methods that we are having, you are moving from a given point. And if you are giving from a given point, so access is very easy. If one file is lost, automatically the other will be retrieved. So it is easy to retrieve them. So it is not like the one that we had here. When we lose a content here, maybe we lose a file here, automatically the others that are connected to it now becomes the head of them. So we are looking at a point where we can easily allocate them, we can easily access them, and we can efficiently use them in the method of file access. So in this case, we can say there's the best algorithm, there's the best method, because one, it is more efficient. Two, you can allocate the file very easily. Three, there is no loss of the files when you're accessing them. If one file is lost, the other still will be accessed in a given point. So the best one is indexed. Then followed by now the one here we are calling linked or chained. Then the last one is this is a traditional one, because you have a lot of external fragmentation. We need to avoid these external fragmentation when you're trying to communicate using different servers. Have I answered that?
Yeah, I have another one.
Yes.
In directory, types of directories, which two directories allow transfer of files?
Two-level directory, yes, allows transfer of files, but within the same directory. Okay. Meaning, if it is a user one, you cannot transfer file to user two. You have to transfer files or directory in that user. That's why when you see the directory that we are having here, we are having a two-level directory, but this two-level directory has users. So this directory can only transfer files to the user one. Then user one maybe can transfer it to directory through. But now the issue that we have here is that directory one cannot share. Directory one has file one. So file one cannot be shared by directory two. It is only for directory 1. That is the only problem that we have. But we allow transfer of files from user 1 in that directory, but not from user 1 to user 2. It is from user 1 to a directory, and not from a directory to files. So users can transfer directories, either those directories that we are having within the user, but now files cannot be transferred to different directories in that user. That is why we have that issue of communication when you're using a two-level directory.
Okay.
Yes, any other question?
Now,
Kalani, do you have any question? Karani. Sianka, Gomia.
I'm okay. Yes.
Oh,
Yes.
you are okay. So is it possible that we can? Is it possible that we can maybe continue?
yes.
Okay, so let me give you maybe 5 minutes, maybe to ask yourself what you have not covered from the introduction of the files to where we have reached. So please, I'm giving you 2 minutes. Maybe you look at where we have an issue.
The general graph directory. Representation of files.
General graph directory. So in a general
Yes.
graph directory, I have said it is the same as a cyclic graph directory, but we allow interchange of directories. And that's why we have the interchange of directory. So if you look at the acyclic, we don't have interchange, meaning this directory cannot interchange its concept or data. It cannot. It has to change it through file, or it has to change in one way, like the one that we have here, where directory is sharing with this directory. But we cannot have an arrow that is pointing towards this directory again. That's why we find that this, when you're using the general graph directory, it is more efficient in terms of presenting more directories, small directory or few directories, which can try to create interchange of cycles. So this is the first cycle that we are having. We can still create another cycle from here. We can create another cycle from this file to this file again. So that is what you are supposed to understand within that. Maybe you can ask a question.
Thank
Hey.
you. Karani kwani yako offline?
Yes, alikuwa ameingia ako amemute.
Yes, are we okay now? Can we proceed? Do you have any issue?
No.
Okay, so the next thing that we are supposed to cover is our file system. But before we go to file system, we need to ask ourselves, if you are having these files, how can you access them? I think I have talked about their file access. And one of them that I have talked about is what you call random access. So we have talked about, just a minute. So we have talked about random. So we have talked about random access. And this random access is the one that we are calling it direct access method. And then the next one that we need to look at is what you call the sequential. I don't want to go beyond this point because you understand what is sequential file access or sequential file access and indexed file access. Meaning, when you're using random access, you can just go to a specific file. You don't have to follow a certain procedure. You go to a specific file. Sequence, we move from one point to another. That is, you're not supposed to jump files. Indexed, you're using a certain key field to access them, and that's why we always say that when you're using indexed is the best one to use, because index will be able to resist from the loss of data, because now in this case we are moving from a specific index or a specific point of access at that point. So in this case, when you're accessing these files, we must always provide what you call security on these files. And for you to provide security on these files, you either can do one, use password. Maybe you can use password of a directory. And maybe you can do some what you call encryption of these directories. So you do some encryption. At the moment you do all these things that we are having here, you must make sure that now there must be a specific structure that does that. And that structure is the one that we are calling the file system. So that is why the next topic that you're supposed to discuss is on file system. Because when you provide security on a specific file, are you able now to provide the encryption? If you're able to provide the encryption, meaning that if this is a text, you can change this text to asterisk, or maybe in a form that the user will not be able to understand. You can be able to maybe change the mode of communication when you're using these maybe files that you are having. You can provide file security in directory level. You can provide it in different files that you are having. And in this case, if you look at this aspect on file system, one of them is what you call FAT. We use FAT. Maybe we use NTFS as file system. We use FAT32. We can use NFS. We can use HPFS and many others that we can use. Mostly these ones are for Windows. But what about for Linux operating system? Maybe you can use x32. We can use BUFs. We can use CAVs, file systems. And maybe we can use XL3 and 4, etc. So if you can be able to use these methods of access, it will become easier for you to access the files that you are having. And that's why we need to look at now the file system. What is file system as a structure in that area? So is there an issue on security? Is there any issue on security? Maybe we proceed on what we are referring to a file system. So let me look at security. Let me look at, so the file access methods. Already we have talked about those file access methods. So we have talked about linked access, etc. Then we look at the operating system security. So that's why we are saying security refers to a provision of protection on a system. And we always provide on something like CPU as a resource. And there is a question that you can be asked in operating system. name 5 resources or 2 resources that are mostly used in operating system. One is the CPU, the next one is the disk, the next one is the file, maybe we have the hardware, etc. And we are saying we can use this method of access or these methods of protection. One, you can use authentication, you can use a one-time password, or many others that we have. When you use a one-time password, is the password that you can use for a given time. But now, why are we protecting it from security? Maybe we are protecting from the Trojan horse, protecting from the virus, and many others. So I think this is not new to you when you look at security in operating system, because the only way that you can provide security in operating system is through provision of encryption and through provision of passwords and many other methods that we have already discussed. So the next thing that I want us to discuss is on file system. And when you look at the file system, we are saying it is used to determine how data and programs are accessed. So the moment you are using an operating system, mostly what determines how the operating system is, how the data is supposed to access is the file system. So that's why sometimes we call it a structure, which determines the level of accessibility to the users. Maybe how many users are able to access the file, when are they supposed to access the files, in that way. Just a minute, I respond to a certain call. Just a minute, please. So in this case, we can be able to understand that if you have these file systems, you can be able to provide a clear access within the files. And when you provide a clear access to the files, it's very easy for you to provide the mode of access. And that's why we are saying one of them that you can use is what you call the FAT, file allocation table. And in the file allocation table, we are saying is used by the operating system to locate files on a disk. But the question that you're supposed to ask yourself is it able to provide security in folder level? No. So when you're using this kind of a file system, it doesn't provide security in folder level. That's why it is not mostly used in nowadays. Because this FAT is the one that was called FAT16. FAT16. But when you use this, you must be able to understand that security is only provided by naming. So one thing that we need to understand about the FAT is that security is provided on naming. So naming, security is always provided, it's not provided. Not provided on folders level. Not provided on folders level. Then, if you look at this method, is not efficient in file allocation. File allocation. When you use in naming level, we are saying how many characters should you have? Maybe I need to have 10 characters. So if I have 10 characters, you will be able to provide the access. So if they are able to provide the access, it becomes easier for that access. So that is one thing that we need to know. We are providing naming, but when you provide naming, it is able to provide 10 characters. Or how many characters should I provide? Will you be able to remember those 10 characters? So if you cannot remember them, that is now the security. So in this case, it was providing 8 characters. And these characters, we now add the 3 characters for extension. Like now, if I have my file .doc, remember the file extension should always have 3 characters. It should always have 3 characters. That's why we always have .xls, .pdf, .rf file, etc. So out of this, .wav for audio, this is for audio purposes, .wav, etc. So in this case, we need now to understand if we can be able to provide this file, and we are able now to provide 8 characters. So it means we need to have 8 characters for file naming, then 3 characters, which is supposed to end up 11 characters. Which is somehow very complicated for us to remember those 11 characters or those 8 characters. But there are those people who can remember that, so it is not all that secure. So in this case, that's why the next file system was able to provide a more mechanism on file provisions, on security. That's why we went to what you call the FAT-that tool. And if you look at this, we are saying naming convention, provide file name of 8 characters long. And most of the operating systems that were used, it was Windows 2000. Windows 2000. So you can see now the generation that we have currently. The generation that we have currently, it is a generation of Linux operating system. So in this case, we now provide a very inefficient use of access, and that's why we were able now to go to the next file system. So if you look at security, it does not support local and folder security. So provision of security in folder level, it was all in vain. Then when you look at the FAT-that tool, we are saying it is an advanced version of a FAT file system. Used to drive 512 MB to 2 TB in size. So I think now you can see the size. That one was too small to be accommodated on that. So the features that were provided here, mostly you find that now the partition size was increased. So we are able to increase the size. The access speed was increased. If you want to access it, it's very easy for you to access the file. You are able to provide a clear mechanism of file access when you're using this mode of access. And that is now why FAT-that tool is still used today. We can still use it, and we still use it. But if you look at the usage of this FAT-that tool, you find that now, because we can provide a good size, it doesn't still provide security in folder level. We can still have some issues on access. We can still have some issues on relocation that we always have. That's why it becomes an issue in the file access we have. The next one was NTF, New Technology File System. And the New Technology File System, it was able to provide security on different levels of access. These different levels of access, we are looking at naming, which was able to accommodate 5 characters and these symbols that we have here. When you look at security, it was able to provide security in folder level, which is now safer than when you use the FAT method, or maybe FAT method, or FAT file system. Partition size increased because when you look at this file system, it is still used in network operating systems. So when you go to network operating system, we use NFS, network file system. But in this case, it's just a conversion of structures that you find within the NTFS. So that structures are slightly converted, which allows you to communicate in that access. So we can be able to find some improvement in these access. We can be able to provide some flexibility in these access that we have. Then when you look at the compression, you can compress. That's why up to now you can still compress the files. You can reduce the size, maybe using some softwares, maybe WinRAR. You can use WinZip or Zip that you want to maybe to compress the file. And reliability is very high reliable because up to now we still use it for the access of that operating system that we have. So that's why we always look at the best operating system, file system that we can use in the access. So this is just an improvisation of this NTFS. Because when you look at this, it cannot be used in networked operating system. Mostly, if you look at now what we were covering on remote procedure calls, I remember I saying you need to create some communication, but this communication of a remote procedure call is where the user is sending, the receiver is receiving. When the receiver is sending, the receiver is waiting for the message to come from the other end when we use some protocol. So in this case, we are now able to look at now the aspect of improving the access, improving the mode of access, because now we are increasing the size of access on that. HPFS, that is a high performance file system, just provision of LAN space. Mostly when you're using the RAID memories, like the data RAID dependent disks, where it can allow more access, it can support more conversion, it can support other security mechanisms. Not only one method of access, you can be provided with various access methods, various access points, various contingencies with the access points. So we are trying to improve that. We are trying to energize the fire access. So in this case, we are able to provide the fire access in a bit of more advanced. That's why we look at this. We can use 512 bytes. We are improving on access. We are improving on the method of access within that. So that is just an explanation of our systems that we are supposed to that assist in access, that assist in making sure that we have efficiency in the access, and we can improve on access on that. So we need to expound on this because our target was NTFS, sorry. We need to look at the structure of NTFS. And that structure is examinable mostly. Like I have seen a question on that, asking you with an example of a structure, can you define what is NTFS? So in that case, you need to understand this. So that is what we are supposed to cover on file system. So file system allows you to access files, allows you to compress data, allows you to move data, allows you to manipulate data, allows you to delete data, and many other things that we have in the operating system. They allow you to transfer data, they allow you to name files, they allow you to provide security, they allow you to create some reliable data, they allow you to create some partitions within the access. So that is what we are supposed to cover for now. If you look at now the file system. What is remaining is the structure of file system, and we rest our case on the topics that we are supposed to cover in operating system. So any question? Any question?
Are the notes on file system in the portal?
Pardon?
The notes for file system are they in the portal?
Okay, I have said I will send them. I have not sent them. I will send them. I'm sorry, I have not sent them. Immediately we end our class, I will send. These ones I'm using for the class that I was teaching on those people who are now in semester 3. So I was using these notes. They are in their portal, so it is not in your portal. So I'll transfer them to your portal. I was using them from their portal. But in your case, I will post those notes today. Is there any question up to that point?
Okay.
Now, I don't want to start on file structure. Let's end our lesson on next week, so that now immediately we can start our revision. You can start our revision. So next week, I will have a very short class, maybe 1 hour or maybe 30 minutes. So that we end on that file system. Then immediately after that, I wanted us to do some quiz. That is from next week. On Wednesday next week, we'll do some quiz. And that quiz, I'll call it part 1, part 2. Is that okay?
Okay.
So we'll first of all go through our last topic that we are supposed. I think I can, maybe I don't have that structure. Maybe let me look whether I have posted it in this portal. So NTFS file structure. So this is the NTFS file structure. And when you look at the first one, we have the partition boot sector. The second one is the master file table. The next one is the system files. And the next one is file area. So if you look at the partition boot, it is the one that allows you to create some sectors. So partition boot allows you to create some sectors on a certain drive. Right now, when I'm using a DVD drive, when I'm using not drive, so disk. When I'm using maybe a hard disk, so in that, it is always created or it is always presented with some sectors. So these sectors that we are having, they are created by what you call the partition boot. So after the partition boot, we must always provide the structure of access. So we can say this is the first disk, this is the second disk, this is the third disk in the access. So in that, this one is used to store the allocations of access. Then the system file, these are all files that are on an operating system. Maybe we have the communication files, we have the processing files, we have the distribution files, etc. The file area, this is where we want the file. Me as a user, I want this file area. I want the file area. And that's why now we need to understand that when we are having the NTFS, we can be able to look at now the file itself having a partition master file table, which is supposed to allocate. Where is it supposed to be allocated? When are we supposed to allocate? So it's creating some mirrored records that we are having. Then after that, the system file. So we'll be able to revisit this next week. Then after that, we end. So you can look at most of the functions that you find on NTFS. We have encryption, we have this quarter, repass point, we have all mount point, repass files, distributor linking, trunking. So those are all advantages of NTFS file. And that one is just an implementation of what is called the encrypted file. So we can provide that encryption in each of the files we have. So what we have here is just what we have already discussed. But the only thing that we don't have is what are the functions of application. And I have already said this is mostly used for creating sectors. Master for allocation, for storing. Like now I can say this is the first allocation, the second allocation, third allocation, fourth allocation. It is supposed to be stored in a master file table. Then the system files, I pick it maybe to distribute file. I pick it to process file. I pick it maybe to do some other functions that you can do on a file system. So there are many file systems that we have. Maybe we have the system recovery. Maybe we have the system backup. Many others that we have. Those are all files that we find within the operating system. So these are the specific files that you can work with in the access. So that is what we are supposed to cover. And I think if you have an issue on this, we will be able to come back to it and maybe rectify some issues that we have not covered in that point. So is there any question at that point?
You put the notes.
Huh?
The notes.
The notes I will send immediately after we end our class. I will send them immediately. Remember, we are supposed to start from this file system. I will send them from this point. So, if there is no question, I think we can end our lesson now. Is it possible? Can I give you free time? We end our class, then we meet next week.
Yes.
Yes. Let me send those notes so that you can look at them. And the next week, maybe we can do our class.
Yeah.
Yes, please. Next week, we will start with our card and make sure that you do your card. We still require those marks for next.
Okay.
Okay, have a nice day.
You too.